Let's go. Yeah, we're ready?
Yeah.
Okay, so I think it's kind of an emergency talk, so I was not scheduled for...
Thanks very much.
Yeah, I prepared the slides just a few minutes ago, so you will have to excuse me for, maybe for the low quality of the presentation. Well, I'll do my best. I'll try to do my best. So I will try to show you what I think is seven worst things we can do with our software projects, according to my experience and my opinion. And this is not about the problems when the product doesn't work. It's more about stuff about organization of how we organize projects and how we manage them, technically. So it's not about management, it's more about technical aspects. And there will be 7 of them. 7 of them, the most critical at the bottom, and then the first 6, and then the number 7. So let's go one by one. Number 1, ad hoc releases. The release is when you get get your source files, like let's say you have Java project. You have you get the source files, then you test them, then you package them, then you create a jar file, or you create something which is deployable, which can be actually executed, and you put it to production. So this whole process I'm calling release. In most cases, in 99% of projects I've seen in my life, this process, this whole way from starting from files, from text files, to the product which actually works on production inside a container or not inside a container, on a mobile phone or on a server. This process has pieces, has elements, has steps which needs still to be done by people. So we package something automatically, then we do something manually, we put some passwords, some keys, we do some instructions, and then we package something else, and then we again configure a little bit, and then we put it to production. So it's always somebody sitting in front of this process and touching these buttons and seeing how it works. And this is what I call ad hoc. So it means that something will happen according to to me, if I'm the manager of this process, then I will have to make some ad hoc decisions here and there. So it's not fully automated, that's my point. We need to automate projects, we need to automate this deployment cycle completely from the beginning, from text files to the working software. And this automation should happen, and this release should happen by clicking just one button. So if you in your project can click the button and then sit and watch how it happens, and then in 5 minutes or 5 seconds or 50 minutes or 5 hours, you have a working product with the release number 5.7. Then you have a properly automated release. You don't have this sin. But if you don't have that, if you need to do something manually, if you still need to get the files from somewhere, package them somehow, and then run some script and then do something again manually, then you still have this ad hoc release. So this is the problem number 1, which in most cases I see doesn't work like that. We don't have that button, but we need to have that. Why it's important, a little bit of explanation, why it's important. It's mostly because we, programmers, are the most critical element in any software project. The more programmers, the more human factors we have in software, the worse it is for the software itself. So an ideal software project has to have everything configured, and there's a button here which anybody can touch. So I can remove the entire team of programmers from the project, remove everybody. The new team comes in, and they can touch the button, and everything happens, and we get the new release. We had the release number 5, now we have release number 6. So if this is possible, then you're good. This is sin number 1. If you don't have that, you're in trouble. Problem number 2, which I also experience a lot, is untraceable changes. If I'm a developer, I jump into your repository, your environment. I'm a new programmer for you. You're already working for that for 2 years, and I'm jumping in. I should be able to see for any change made to the source code, I should be able to see why this change was made. So what was the reason for that particular change?
And not just to the source code.
And not to the source code. Everything, that's right, yeah. What else is left besides source code? But yeah, I think, So probably for everything, yeah, because in our case, I think everything is kind of, it's not so, well, let's say, yeah, not only for Java files, but for all the files, let's put it this way. Not only for source code, which are executable code, but for all the text files you have in the repository. I should be able to see why these changes are there. For the scripts, for the source code, for the documentation, for everything. I should be able to understand and trace back all the changes made in the code or in any other artifact. Trace these changes back to the original cause, to the original answer to the question why. So I need to know why this change is there. Who asked for that change? How this change was discussed and why the decision was made. And in order to achieve that, it's not so difficult. First of all, you need to put, that's basically 3 rules, which I would suggest. First of all, you need to have tickets in your development. So when you develop the code, you need to have tickets where you, a little bit or a lot, discuss why you make changes. So in most cases, when I see projects, people are just developing code and committing their code to repositories. Just commit, commit, and commit. So you see a huge number of commits, a few thousands or tens of thousands of commits, and then you have 15 bugs. So basically, the question is like, how these 5,000 of commits coming from 15 bugs? So why did you guys make this 5,000 commits? It should be different. It should be a few thousand bugs or a few hundred bugs, and then a few thousands of commits. And each commit, I can link back to the reported bug. And in the bug, if there is a discussion that says like, hey, we're going to fix it that way, and then the answer is yes, probably we should do that, and then yes and no, and then they commit. If you look at the properly organized open source projects, you will see how people are doing it there on GitHub. They usually discuss stuff there, and then they submit the pull request, which is linked to the original ticket. So first rule, just use tickets. The second rule, always in your commits, in your Git commits or whatever you use, subversion, always put the text in there, explaining why you're doing that change. Because later, when time comes, when after a year of work, we need to be able to jump back a year back and see why these commits were made. And some people even configure their local Git installation to make like an empty commit always, or just simple text like command, command, command. Then you open the repository, you see like thousands of commits, and for all of them the text is command, command, command. This is wrong, and I see it a lot. And number 3, don't delete stuff. Don't delete anything from the repository. The repository, your history of development, is what makes your code, your repository traceable, what makes your changes traceable. So don't delete file, don't delete the history of commits. Some people think that this is temporary. So we make commits, we change stuff, and then one day we can grab the entire source code, put it somewhere else, and forget the history. We just start from scratch or whatever, we don't care about the history. The history of commits is as valuable for you as the source code by itself. So it's not just your project is not just a collection of files, it's the files with the history. And the value of this history sometimes is way bigger than the files by themselves. That's number 2. Number 3. I'm just throwing too much probably information, but try to digest. Number 3, static analysis. How many of you know what static analysis is? Oh, great. And in most cases, I'm sure that most of you do this stuff voluntarily, which means that we have the source code, we run some static analysis tools, and we get some numbers from them. They give us some complaints, they say what pieces of code are not so good, they complain about the code. And we just read this information. They build so nice, good-looking HTML pages which show where exactly our code is so good or not so good, how many rules our code violates. And then we just look at this report, discuss it for a few minutes, just put it aside and continue working. That's how it works in most cases. And the question is, why do we need static analysis in the first place? I believe that this is the wrong approach. Static analysis is not to inform us, but to force us to do things right. So it's not about just telling us that our behavior is unacceptable. It's basically to prevent us, to stop us doing that. So if, for example, we have in static analysis the rule which says that we should put the comments for all classes we create. So for all Java classes, we need to have this java.comments. For example, that's a rule. And then we have thousands of files, and we run the static analysis. And static analysis says, for 50% of files, you do have the documentation, this block of text. And for 50%, you don't. We don't need this. We don't need to collect this information. We need to enforce the entire team and us, all the developers, to make it 100%. So if we decide that our static analysis rules are to be that way, then we need to run this analysis every time we release. So every time we push that button, which I talked before, we need to run the testing and packaging and everything and static analysis. And the static analysis has to be the step which can stop the release cycle if something is violated. If the static analysis rules are violated, we need to stop the release. We shouldn't just report, we shouldn't just build a nice, good-looking pages. We need to stop the build and do not continue, because our code violates our own rules of static analysis, which is not the case in most cases, like in all projects I've seen before. It's volunteer static analysis. I believe it's wrong, and again, there are many, I can give you a few examples. One, the check style for Java, or Rubocop for Ruby, or PHP-CS for PHP. So for each language, we have a tool on the market. Maybe for the Swift, we don't have that tool right now, or maybe for Go, I'm not sure we have the tool right now. But for all languages which are at least a few years on the market, we have static analysis tools, which will actually help us to run through the code, see how it's designed, how it looks, how it's, how uniform it is, and then we'll complain about certain pieces which are not so good. So we need to make it mandatory, not volunteer, but mandatory. Number 4, undocumented interfaces. That's another problem which I see a lot in the projects, is that it's basically a lack of documentation for people who join the project, and for customers who are trying, for people who join the projects, and for product owners, and for everybody. We do not document interfaces through which our software communicates with users or with other software. So it's basically a lack of documentation for external parties. So we write documentation quite often for what's going on inside the product, how we design stuff, we write some diagrams, we create some documentation for ourselves, but we do not explain clearly and explicitly how the software is communicating with their users, and with their other software pieces which it connects to. So this problem I see not so often, but I think in general, in most projects, it's just the product is there, it works this or that way, the team is working on it, the code is somehow organized, but it's difficult to understand what it does in the text form. So if you get the software and run it, yes, you will understand if you're on the same domain, if you understand what it's for, then you will understand how it works. But it's difficult to understand just by looking at the repository, what this repository is about. Only properly designed and quite popular open source projects are done this way. You can open their GitHub repository, you can see their front page, and you will see like 5 pages of documentation which explains what it's for, how it's done, how it interacts with you, what you should expect, and things like that. In most cases where projects are not so popular and people are not investing that much time into them, it's difficult to understand what this product is for. And this, I think, is a problem. Not a huge one, but it is a problem. Number 5, we have 3 to go. Unknown test coverage. This, I think, is a big problem. Again, how many of you knows what is test coverage? Great. And how many of you actually know the number in your project for the test coverage? See? Way less. What type of number? Some number. Let's say the overall number. So not so many, as you see. So the percentage is not 1-to-1. So this is the problem which I think is quite serious. So the test coverage, just in general, is just we need to run all the tests, all the unit tests. And then we see how many lines of code, or how big is the percentage of lines of code, or functions, or classes, or something. Actually, our unit tests touched while they were running. So we run them, and then we see what's the number. And then in most cases, people again ignore this number, or even more often, they just don't know this number. So we do have the code coverage. We do have unit tests. Do we test it? Do we check the code coverage? Yes, we check the code coverage. Do we know the number? No, we don't, or we don't pay attention to this number. In a properly organized project, we need to collect this number. And what's more important, we need to give this number back to programmers and ask them to keep this number above certain threshold. That would be the ideal scenario. Again, like with the static analysis, we should put this test coverage into the release cycle. So every time you push the button, that button which I mentioned before, every time you push the button, you package everything, you test everything, you do the static analysis and check that your code actually doesn't violate your own principles of quality. And then you check what's the number of the coverage, what's this percentage is. Is it 80, is it 30, is it 10? And let's say we aim for above 50. So everything which is above 50 is good for us. If it's lower than 50, we not release. We just stop the release cycle and we don't put it to production. If you can make it that way, that will be perfect. Because in this case, you will control the quality of your product. You will control your software project. Because if you don't know the test, if you don't know the coverage at all, or you don't check it, don't control it, then you basically don't control the quality of your software. You don't know what's going on there. Because the tests and the code, they should go, in line with each other. So the tests and the code, they should go together. And if you don't know how tightly they go together, how much code your tests actually control, then basically it's the same as if there would be zero. If you don't know this number, you cannot manage the project technically if you don't know how good are your unit tests. And this metric is #1 metric in terms of unit testing. So if you want to know how good you are in terms of testing, you need to know this number. And not just knowing, but knowing this is the first step. In most cases, people just don't know the number. They control coverage, they see some reports, like with the static analysis. There are HTML pages, huge HTML reports. You can click on each file, you can see how many lines are here and there, but the overall number is what people, in most cases, don't know, and very often they don't pay attention to this number. But I'm asking you to pay attention to this number, and even better, control this number. For yourself, even though if there's just one developer in the project, if it's just one person working on the code, still, if it's just your personal project, you need to know this number and make sure that you're staying above certain line. And there are many, like this is the right comment, there are many numbers, it's not just one number. But if you start doing that, you will see that there are some numbers are more important, some numbers are less important, but you need to start focusing on these numbers, I believe. Number 6, non-stop development. That means, again, quite often, we just keep making changes to the code, we keep making changes, and we sometimes put this code to production, and we package it, again we make changes, again we put to production, month by month, year by year. We don't stop and make versions. We don't versionalize our product. We don't say this is version 1.7, and in 2 weeks it's going to be 1.8, like it's done in open source development. You always know what version of this Apache Hadoop is. You always know the number. They do it not for fun, but they do it in order for traceability and ability to roll back, to step back, and actually to guarantee stability of development. So we need to do the same for all projects, for commercial, for open source, for all projects. So we should not develop non-stop. We need to have releases and milestones. We need to have these numbers, and we need to do it as frequently as possible. Ideally, every time you make some changes to your source code, every time you fix some bug or do some changes there to the code, then you click the button, you give this button a version, like 1.17.3, because I just fixed the bug. So 0.3 means this is the next minor version, so I just fixed the bug. The full packaging is happening, the full release cycle is happening, and the code goes to production. And your customers will see, okay, now it's version 1.17.3. And then boom, something doesn't work, and then we need to change some format, a little bit of this button. We change this button, the version is 0.4, 1.17.4. Again, we click the button, again everything goes to production, and we are getting another packaged solution with another version. If something is wrong, we can roll back to the version 1.17.3. So we need to have these fixed versions of our software. It shouldn't be non-stop development. It shouldn't be just the code here and then the product on production. They need to go in milestones, in steps. This is very important, I believe. So there's non-stop development. Quite often you can see it in like commercial projects where nobody's facing you, just a group of people. The source is closed, it's not open source, and then we just continue developing, and then in a year, maybe once a few months, we're just making version number 1, and then okay, let's make version number 2. This is wrong. So think about how you version your software, how you give these numbers, and make sure that this button which you click, this whole release cycle, actually takes this number from you, package everything, label it properly, and then in repository you also have, if it's Git for example, or Subversion, you have tags for these versions. So every version must have a tag. That's again sin number 6, which I see a lot of people are not respecting. They're just not doing this version. Why it's happening? I think because people think it's kind of redundant. It's kind of an extra work, because you do need to do some extra work for that. It's way more easier to just drop your changes to the code and then wait for them in production, or just make changes to the source to the repository. But in the end, you will have problems with the maintainability. In the end, when the project is 1 year old or 2 years old, it will be quite difficult for you to get back and to, say, release the version which we had in production a month ago, or to see how it worked, or to see who made the changes and why, because you don't know where the changes were made and what version they were applied to. So look at how comfortable it is for us to work with big open source products. When you know the version, they provide support for different versions, they report why this version was deployed. If you look at this big Apache products, then you will see the open source. You will see that for each version they provide these release notes which explain what exactly was done there and why. So this is exactly the same we should do with our projects. It's not so difficult, it's not going to take so much time, but just half an hour or something for each major version which you release will greatly help, first of all, yourself, not only your users. And the last one, anti-patterns. This is more about coding. So I think this is, I actually wrote a blog post about all these 7 sins a year ago. And there, this one stays on number 1. But today I put it in the end. But I think this is the most important one. So this means that basically it's a problem, it's a mistake of an architect who is in the project. So the architect, anti-patterns, you know what it is, right? So it's basically the methods or the way we design our code so that we allow ourselves to make certain mistakes again and again, and these mistakes are well known to be not acceptable in certain programming paradigms. Let's say if it's object-oriented programming, then it's well known that a singleton, for example, is not really a good pattern, it's anti-pattern. So if you use singletons, if you use them a lot, then your code eventually will start to, the quality of your code will start to degrade in time, and you will have bigger and bigger problems with your code. So my point here is that the software architect must enforce on the team certain rules about how we design software. Not just we do it because our customers are paying us and we just need this functionality. But the architect has to say that we do not do this and we do that. Not in terms of functionality, but in terms of our design ideas and design approaches. And the best way to do it is not actually to promote patterns, but to say what are the anti-patterns. Not to train programmers and say we need to use these particular features and everything like patterns, but to say we should not use this anti-pattern. For example, the singleton. I'm just giving an example. The singleton is something we should never use. And the architect must keep an eye on that and control how many of these anti-patterns are actually being used in the code. And ideally, there should be, in a project, there should be some certain guidelines or some list of things which we never allow in our code. What kind of anti-patterns we do not allow. And now a little bit of self-promotion, and I'm finishing. So I wrote a book a few months ago, which is called Elegant Objects. It's about object-oriented programming, which actually lists that anti-patterns which should not be used in a properly designed object-oriented code. So this book, well, I wrote, being an architect in many projects, I've seen different kinds of these anti-patterns and things which people are using, which they shouldn't use. And I was telling them again and again in different projects what you guys should use and why it should be different and what exactly we should not use. And then I decided to write a book. So I'm kind of promoting the book now, and I'm suggesting that you, in your projects, well, not necessarily write a book, but do something to show your programmers what exactly you're not ready to tolerate, what kind of design solutions are not acceptable in your code. So that's probably it. That's what I wanted to say. And now questions. Yeah.
At the sixth sen, you mentioned that the non-stop development is a bad thing, and you said like it's a requirement actually to number every release. But how would you do that if you have multiple branches on that, or at least multiple developments happening on that same branch?
Feature branch.
Well, how it's happening on the open source products. They have version 0.3, and then they have version 0.4, and then they get back to 3, and because people submit bugs, and they keep making 3.1, 3.2, while version number 4 is still going forward. So you should be able, that's probably a good question technically, you should be able to release from a different branch. So you should configure your release system so that you can release from any branch, not only from master branch. So you should not be just doing it in one thread, but you should be able to branch out something, make the changes, and release the version which is of different number, or maybe the number which is way back in history. Let's say you have version number 3, and then we're already in 4 point something, but then the bug comes in for the version 3 for the user who is still using number 3. So we need 3.1. So your system should be able to package everything and test everything from 3.0 and make it 3.1. And then it's called backporting. It's the technology which is probably somebody heard about that. When you have the higher version, and then from the high version you need to from the lower version you need to make that changes to the smaller version like 3, but then you backport it to version number 4 because you need it there as well because you're fixing some bug there, but you still need it in a higher version. So it should be the functionality from your release system. You need to be able to do that. But it's always important to keep numbers for the versions. Yeah?
Instead of trying to enforce things, it might be better to just only build the code that's covered by the tests.
Yeah, definitely. Yeah, that would be ideal. Yeah. I mean, you release this and you don't release that, or in general, the whole.
What you create in your build is only the code that is covered by tests. Everything else is not built, so you cannot release it.
Yeah, definitely. That would be ideal. Yeah, of course. So you're saying that we need to check before we even go for release?
Yes.
Yeah.
You don't want to enforce a rule, you just say, if it's not in.
Yeah, absolutely, absolutely. That's what I mentioned. So when you configure the release, when you configure your release and you make sure that the release is automated, so everything happens on the click of a button, then there basically is going to this release process, or the recycle so-called, will contain a number of steps. The first step is probably going to take everything from repository. The second step is going to be probably compile everything. And then the third step is going to be probably test everything, run unit tests. And then you check the coverage, for example. And then you check the static analysis. And then you check integration testing, for example. And only then you put it all together into Docker container and put it to production. So if any of these steps fail, then you fail the whole thing and say to developers, this is your problem now, fix it. We're not going to release that. That's perfect. That would be ideal. Yeah. So these the first, basically 3 problems here. First of all, people do not automate it that way. So people just don't have this button. We don't have that button. That's the first problem. The second, we don't put static analysis in there. Third one, we don't put test coverage in there. And that's three elements which we miss a lot. Many projects miss them. And I suggest you to think about that. Yeah.
Yeah, you talked about documenting interfaces. What is enough documentation? What kind of documentation is sufficient according to your opinion?
Well, in general, in general, it has to be small enough to be understandable by programmers. So in general, documentation is a bad thing, as you know. I mean, the more documentation you have, the bigger is the trouble with the source code. So the source code and the code has to be self-explainable. But interfaces is something which is aside from the source code. That's why we need some text in there. But we should keep it as small as possible. That's my, personal from the practice. Because if you make it big, if documentation starts to grow, nobody's gonna read it, and that will be just something which nobody pay attention to. So in general, it has to be as small as possible, but it has to be there. We cannot just ignore it and jump into the code and create something for ourselves and just understand it and don't care about how our users understand it. So we need to build this bridge between us and the users by introducing this documentation for interfaces. Yeah.
The documentation for an interface, it should be exactly as long as the unit test for that interface.
It should be, it's close, but the integration tests, they come and go. You write them and then you delete them and then you refactor them. They change the image. Sometimes they just don't pass and we delete them. It happens. But the documentation is more about the purpose of what we're doing instead of proving that it actually works. The integration test, I would suggest that the integration test follows the documentation of the interface, but not the other way around. And integration tests, ideally, we need to have many of them, hundreds of them, even for one small interface. The more integration tests we have, the better. So I would say that integration tests are longer and documentation is shorter. That's how we compare. We're done? Thank you very much. Oh, yeah.
Sorry, one question. You mentioned SIM2 and traceable changes don't leave commits. Where do you stand on squashing feature branches? So when you introduce a new feature, some people tend to squash the commits before they get committed into the master branch because they tend to think that
Yeah, I
you
understand
don't
what you're
need
talking about.
to know how they got there. This is how we implemented it, and all the changes that came before that aren't relevant for that feature.
Yeah, I understand. A few years ago, I thought that squashing is bad. Now I think that squashing is good. Squashing is good. So I'll give a few words about what we're talking about here. So when there's a long history of commits, and then when you branch out and start working on some feature, you're making your own commits. And while you're working on this feature, you're making some changes with the code, and not all of them are so important. I mean, this is your personal work, so you work on your own branch. So you make commits, you think, you go back and forth, you develop it. And then you want to move these changes back to the master branch. So when you move it back, then you merge it back, then originally how Git works, it gets all of these commits and just move them all together to the master branch. So later we'll be able to see how this programmer actually was doing that, like step by step. So we'll see all the 15 steps which the programmer passed. And then the question is like, and there is another feature available in Git, for example, when you can put all these commits together, so-called squash, and make one commit of them, just one change, and put this one change to the master branch. In that case, later we will not be able to see how this programmer was actually thinking. We will not be able to see all the 15 steps. We will just see one step, as if this programmer just branched out, made everything from one step, and returned it back. Like he was so smart. That's actually how it's going to look. Yeah. So we'll not be able to see the thinking process. And the question is whether it's good or bad. So which way to go, to squash everything or not. In our project, we don't squash because we think that it's important to see how people think. But I'm not saying that squashing is bad because I've seen it's a question of taste. Some people do squash, some people leave it like that. The long history will be long because in the branch you will also be able to see the timing of that. You will see when the branch was started, how this commit was made, when exactly that happened, and what's important, you will see comments for these comments. So you will see 15 pieces of text. Like, I've done this, it doesn't work. I tried that, it works better. Oh, it doesn't work again. I tried that again. So you will see this text, which will make your history way richer, way more valuable for you in the future. Like I said, the history of commits, I think, the history of repository is very important. Sometimes it's even more important than the piece of code you have. Because it's basically the entire thinking and development process. It's not just the final result. You may have just, 10 files in your project. Just 10 simple text files. But a long history of 3 years of development. So these 3 years of development, it all stays in your history, in your Git repository, which may take like gigabytes of data. And then just in the end, just 10 text files. Like look at this, say, Docker project. It's not so big in terms of source code. It's not huge, it's just text files here and there. But the history is enormous because people are making a lot of changes. And you can see why. Sometimes you open one text file, which is just, I don't know, 20 lines of code, and you see like 25 people contributed to it. So 25 people worked on this file and did something with it. One guy made one change, another one made one change, and you want to see that. You want to see the history of that file. And removing that and just saying that our files is our asset, this is wrong. So keep the history and work on that history. So make sure this history looks nice as your code. So you comment everything, you ask that question, what's good squashing or not squashing. That's a good question. It means that people care about how this history looks. They just don't drop everything there and dump everything there and just, okay, this is our asset. These 10 files is what makes our project. No, they care about what's there, what's in the history. So the Git repository, I'm sure most of you use Git, so this Git repository is the actual value, not just the files you get there. That's my message to you. All right, I think we're out of time, almost. Thank you very much.